I picked that formula. That's what I picked. I don't know. You might have picked first, second, third formula. I don't know. So what is cosine of u squared minus sine of u squared? Well, I know sine of u is this one, 3/5, right? And cosine of u is 4/5. Oh, I got it all right here. That's all it is. Okay, well, what's 4/5 times 4/5? 16 25ths minus that squared is 9 25ths. Oh, nice. I have common denominators. The answer is what? Yeah, 7 25ths. Now, question, did anybody pick the different formulas? What'd you pick, Skylar?
I did 1 minus 2 sine squared of that.
And did you get the right answer?
Yep.
Yep, okay. Did anybody pick the bottom one? 2 cosine squared minus 1? Nobody did the bottom formula. Okay, big deal. It would have worked. I'm just saying. Okay? All right, do tangent. And tangent, you only have one formula to pick from. One minus tangent of u squared. Like that. All right. We haven't done tangent yet. What's tangent? Tangent's what? 3/4, right? 3/4. So we go 2 times 3/4. 2 times 3/4 over 1 minus 3/4. But it's tangent squared, so you got to square that, right? 2 times 3/4 is what? 6/4, gotcha. Okay, and that's 3/4 times 3/4, so that's 1 minus 9/16, right? And here's that complex fraction again. How can you get rid of that denominator, 16? Oh, sorry, 16 and 4. How can you get rid of it? There's a quick way. Times them both by what?
16.
The common denominator. What does 4 and 16 go into?
16.
16. Pick 16. Okay, so if you pick 16, and you pick 16 here, all those ugly fractions will go away. This is going to go out once. 4 goes in here 4 times. 4 times 6? 24. 16 times 1? 16. 16 times 9 16ths. Well, that 16 is out of that 16. It's minus 9. Final answer, 24 what?
7.
Now, if you chose not to do it that way, that's okay. You could have simply got common denominators, subtracted them, then eventually you would have multiplied by the reciprocal, you would have got it anyways. Okay? So that's 1, 2, 3 different functions on the double angle. Okay? Now, we're going to go here, but not yet. We're going to go to identities. Identities. 5, 1, 5, 2. Now you have to think the double angle formulas. Double angle formulas. See, there's a expression. I'd like you to simplify it so that it says, rewrite this trig expression as a what? Single function. I just want sine or I just want cosine. That's it. So get rid of either the sine or the cosine using your identities we just covered. All those x's, I think Mr. Glaser, you called it omega.
Yeah, it's called omegas.
Okay. We drew our omega differently in the first half a year, so that's why. I didn't know if it was omega. But anyway, just put x or theta. Are you recognizing anything up there that looks like one of your double angles? That is?
Sine.
Okay, what about sine?
Would it just be sine 4x instead of 2x since it's a 4 in front?
Okay, but you're recognizing, I think what you're doing, Hannah, is you're going like this. You're saying sine of 2x is equal to 2 sine of x times what? Cosine of x. Okay, you almost have that, guys. Look, that is almost that, right? So somehow, could you just rewrite that a little differently to make it look like this? I would like you to somehow tell me this expression by saying 2 sine of x, cosine of x, and a little bit more. Okay, watch. See this? 15? Isn't that 15? Right? Okay, I'm saying that can be written differently using that. How else could you write?
2 times
2 times 2 sine of x, cosine of x. Okay, would you agree that that is that? Yeah? Okay, so we rewrote it just like we were doing in 5.1 and 5.2, and then you have to look at it and go, wait a second, what's this? Sine of 2x. So now you're using your identities. You're saying, oh, well, wait a minute. This is 2 times this is sine of 2x. Now, did I write it as a single function? Just sine. Cosine went away. I got rid of cosine. I simplified. I made it easier looking. That's what you were doing in 5.1 all the time. You're doing it again. Just use your double angle identities. Okay, got one more. Try this. Try that one. Using your double angle identities. Try it. You got to write it down, guys. Write it down. Now you can't just stare at it. You got to really think. How would I use my double identities? Or what should I do? Aaron, do you know anything about that? You thinking anything?
I don't know, I was just looking at the first one. I was thinking, like, you put the 2 on it, it would be the same as 2 sine x times cosine of x. You can just factor out the 2.
Oh, factor out the 2. Okay, so Aaron, he looks at the first factor, he says, wait a minute, there's a GCF. Should I do it? Factor out a 2. If I do what Aaron said, he says, just take out a 2 out of the first one. Okay, everybody agree? That works, right? The only thing is sine of x minus cosine of x doesn't look like your double angle formulas. So it didn't quite help us yet. What about the next factor? Take out a 3, yeah. So it says 2 times this times, now you're going to take out a 3, I think, right? And you'll get basically this, right? Okay. So now I got 4 factors, and the 2 factors that happen to be constants, this one, I'll just multiply them and get what? 6. So it's this minus this times this plus this. Okay? Now, are you looking at that, looking at your identity sheet going, where does it say sine minus cosine?
It does.
It does?
Well, it's because it's squared, so like when you like multiply it by each other.
Yeah, see, the thing is, it does say cosine squared minus sine squared on here, but you don't have any squares, but if you do what?
You multiply it.
Foil it out, yeah, foil it, guys, and this is the difference times the sum, so the inner, outer, just what?
Yeah.
They do cancel, okay, so this is what you get. And then inner, outer cancel. Last give you minus what? Okay. Okay. So Everett says this doesn't quite look like your double angle formula. So he says you could make this cosine positive and sine negative by factoring out a -1. So I'll do that. Take out a -1 times 6, and then this would be what? Yeah, I'm going to put the cosine squared first. I'm going to put the sine squared second. And now you're looking, going, hey, that's cosine squared minus sine squared. That's really just what? Okay, that's cosine of 2x times -6. There. We just got rid of all the signs. Yes, signs are gone. We just got cosine. And the idea is to get something that looks very complicated to something that's a little less complicated. Would you say yes or no? Thumbs up, thumbs down. That's not easy. That one is just, takes some time. You have a few of these to do, okay? All right. If you get them right away, those are quick hitters. Okay. Here comes the what? Half angle. So the half angle looks like this. Take an angle, cut it in half is what it is. So here's what they're giving you. Sine of what? 165. 165 falls where? Quadrant what? 2. Okay. So right there, guys, you kind of know I'm in quadrant 2. I can't do that. Because that's not a 30-degree angle. That's actually what? 15 degrees, and I don't know this one. So I have to use a formula, and they want you to use the half angle. So here's what you're going to do, I hope. You're going to say sine of half an angle. I need to take an angle, u, cut it in half, and I need to get this number right here. Anybody know what u is?
30.
What?
30.
30? Just 30. Okay, I'll put a 30 there. Is 30 divided by 2 165? I think it's 330, right? Guys, listen. The answer should have been 330 degrees. Divided by 2 is 165. So here's the weirdest part about this whole half angle thing. I say it's called a half angle formula, but when I give you 165, what do you really do to it to get that?
Double it.
You double it. It's weird. It's called the half angle formula, but you double what you're looking for. Okay, now that you did that, u becomes 330. What's the formula? Somebody help me. Plus or minus square root of
1 minus cosine of x over 2.
over 2. 1 what?
Minus cosine.
Of x, but I used u, sorry.
U.
Okay. Guess what u is? Yeah, it's 330. You don't even look at that 165 because you replaced u with 330, so that goes here. All right? And now it's not bad, guys. The only thing is you got to know where 330 is. Where's 330? Quadrant. 4. It's right here. Here's a 330. Reference angle 30. Okay. Now you just do the number crunching. Go ahead, put something in for cosine of u. So who wants to tell me cosine of u?
Square root 3 over 2.
Yeah, square root 3 over 2. Is it positive or negative? What? Positive x over positive hypotenuse. Okay, so there's your answer, except it's just a mess. It's got a square root, it's got square roots inside, denominators, it's just a mess. So we're gonna clean up the inside before we do anything. How could I clean up the inside?
Cross the twos out.
Cross the twos up, okay?
Oh wait,
What allows me?
never mind.
No, what allows me?
No.
She's right, she doesn't know it. What allows me to cross the two? Multiply the top and the bottom by what number? By what?
2.
2. Look at the denominator. You want 2 to go away? Multiply by 2. Multiply by 2. Oh, Laura and I take that back. You
Yeah.
can't cross them. That's a what? 4. Now this one up here becomes what here? 2. And when you do this, these 2's just cancel. You get minus what? Square root of 3. Now, if you remember, guys, do you remember this? When you have the square root of 7 over 9, back in algebra 2, you broke this up into this over this, right? Called your answer square root of 7 over what? 3. Well, what are we going to do here? Break it up. What's the square root of 4? 2. The square root of that mess, if this was all a perfect square, it would be easy, but it's not. So this is the weird part. It's going to look funny. It's the square root of what you have, 2 minus square root of 3. And that's how we leave these answers for half-angle formulas. Okay? Now, here's the deal. The answer is plus or minus. But you can't have 2 answers.
Has to be minus.
Is it minus? Who says the answer is negative? CC says it's negative. Okay? All right. There's 2 people who are saying negative. The rest of you think it's all positive? You don't know? Okay. Go back to the original problem, guys. The original problem was what? Sine of what?
Positive 165.
Yeah, you guys, I asked you right away, where are you at? You told me second quadrant. Sine in the second quadrant is what? Positive. The answer is positive. So you go all the way back down and you throw out what? You throw out your what?
Negative.
Negative. Okay, that's the answer. Positive square root of 2 minus square root of 3. All of it divided by 2. Okay? Go do number 63 in your book. Just do a half angle for tangent. Or no, I'm saying just do the half angle for sine. We have to do all sine, cosine, tangent, but I just want you to do sine. Number what? 63. Go. You got 7-8 minutes. We can do this. Well, by the way, in your assignment today, 39 and 67 have been crossed out. You want to do that right now? Go to your calendar. 39, 67, cross them out. We're doing 63 right now. And by the way, you do have to do sine, cosine, tangent, the half angle, but I'm just going to do sine with you right now. Here comes the hardest part of the problem right here. What is u?
$45.
45 degrees. There's it. Okay. Remember, if you're going to do sine of pi over 8, and you really can't do it exactly, you have to use a formula. They're telling you use half angle. You need an angle right here. So that when you cut it in half, you go back to pi over 8. And what did I say to do? Double. Just double what they give you. If that's pi over 8 and you double it, you get what?
Pi over 4.
You get 2a's pi, which is pi over 4. So you are right, CC. You said 45 degrees, but that is 45 degrees. So you know what, guys? That is right here. So when you use the half angle formula, whatever they give you, you have to double it in order for you to cut it in half and get back to what you had. That is the weirdest part of the problem. Now you just use your identity. And I already forgot. What goes behind the word cosine? Is it this one, pi over 8, or is it this one, pi over 4? Yeah, this is u. You replace u with pi over 4, so this is pi over 4. There you go. Stick it in, work it out, see what you get. Pi over 4 is quadrant 1, 45. Right? So that's pi over 4. What's cosine of this?
Square root of 2 over 2.
Yeah, it's 1 over the square root of 2, but that's square root of 2 over 2. I got a complex fraction. I'll simplify it by multiplying by 2. 2, and you're going to get 4 on the bottom, right? You're going to get what? 2 minus square root of 2, right? Kind of looks like the last problem, doesn't it? These numbers are a little different. Square root of 4. Square root of the top. Well, these aren't perfect squares, so there's not much you can do, so just leave it. Plus or minus, right? Which one are we going to throw out the window? Minus. Why the minus? Because pi over 8 was the question. Where's pi over 8?
Quadrant 1.
Quadrant 1. And everything's positive in quadrant 1. We're doing sine, but everything's positive in quadrant 1. So we're just going to say positive. Can't say both answers if it's not right. Okay, I shaved your assignment by 6. I know it looks like I only took off 2. I took off 6. Okay? All right, Dad. All right. Hope you did that right now. Knock those 2 off. Tomorrow's review. It's Friday. What's Monday? Bad news. It is a quiz. Sorry. We'll get you as ready as you can tomorrow. Okay? You are so close to me. Who did not give me the assignment today? Yeah. Silver, you did not. Did you? You want these back? You did these?
No, no, yours.
Okay, how close are you? What time did you give me? 7 o'clock? And it's over East Air Force, right? Oh my gosh. You can stay up. Look at you. Take a nap. How'd you get it? I-4? I-4?
Yeah.
No? Yes?
Yeah, they throw it away.
Sure. No? No. Yes, you do.
If you want, you know what you do? You come to my house and you tell me to work on it. Just keep reminding me to work on it. Okay, done.
Well, maybe I should record my voice.
You give me a little recorder. That would work.
How long is it going to take? I don't know. That's a good question. Eddie, I don't know. Eddie, I don't remember.